Welcome to this week's Center of Math Problem of the Week. For this week's problem, we're going to have a problem that has to do with modular arithmetic. So we want to find all positive integers n such that 3 divides n times 2 to the n minus 1. So to do this, we're just going to work a bit with modular arithmetic. We're going to see how some things are equal to other things modulo 3. So say we have some positive integer n, and let's write so let's say we can write our number n in the form 6k plus z, where k and z are positive integers. Now we're going to write n times 2 to the n minus 1, add in modular arithmetic modulo 3, and we're going to substitute this in and see how we get something just in terms of z. So we're assuming we have some positive integer n in the form 6k plus z, where k and z are positive integers. Note that this is saying kind of like, this is kind of taking, if we divide by n by 6, this is the remainder. Yeah. Z is the remainder, k is the dividend, so this is kind of just, and z is kind of which number 0, 1, 2, 3, 4, 5 n is congruent to. This is just a little bit of intuition why we would consider this, but the thing to note, once we substitute in n here, this expression for n, and do a little bit of algebra, you plug that in. 6k is congruent to 0 mod 3, so this term drops out. 2 to the 6 is 2 to the 3 squared, and 2 to the 3 is 8, which is minus 1 squared. 64, which is congruent to 1 modulo 3. So everything modulo 3 kind of works out nicely, and we get z times 2 to the z minus 1 modulo 3. So n times 2 to the n is congruent to z times 2 to the z modulo 3 when we have it written like this. So that means this is congruent to 0 mod 3, if and only if that's congruent to 0 mod 3. So all this just to say that we only need to consider 0, 1, 2, 3, 4, 5, since by division, every positive integer n can be written as 6k plus z, where so by dividing n by 6, and the dividend finds the remainder. The same as saying we can work with n, or we can work with its remainder when divided by 6, is what this calculation shows. So now calculating for whether or not this expression is divisible for 0, 1, 2, 3, 4, 5, we see so a couple of quick calculations shows that for 0 it doesn't work, for 1 doesn't work, 2, 3 also will not work. For 4, we get 4 times 2 to the 4 minus 1 is in fact congruent to 0, and for 5 we also get 2 times 2 to the 5 is also congruent to 0. And so because we only need to look at these remaining terms, we get for our answer, n equals 6k plus 4, or n equals 6k plus 5. So all positive integers with remainder 4 or 5 modulo 6 is our solution. Thanks for watching. Please check us out on Facebook and Twitter, and also check out our blog on centerofmath.org. Thank you.